All right, section 10.7. This is area of circles and sectors. So we're going to be dealing with area of circles this time instead of with circumference. Okay? So another formula that you need to know, put a star by it, circle it, highlight it, whatever you need to do. Area equals pi r squared. We know that r is the radius, so you're going to square the radius first and then take it times pi. So let's just try an example just for fun. How much more pizza is in a 12-inch diameter pizza than in a 10-inch pizza? So for the 12-inch pizza, we would do pi times the radius. And if the diameter is 12, that means the radius is 6. So we would do 6 squared, which is 36, times pi. This is approximately 113.1 inches squared of pizza. That seems like an awful lot, doesn't it? Alright, and then for the 10-inch pizza, we take pi times the radius again. So if the diameter is 10, that means the radius is 5. So that would be 25 pi. So that is approximately 78.5 square inches of pizza. So if we want to know how much more is in the 12-inch than in the 10-inch, we need to subtract those two. So we're going to take 113.1 minus 78.5, and we get 34.6 inches squared. And that's about the size of a 7-inch by 5-inch chunk of pizza. Quite a bit. So if you've ever had the joy of eating at the Incredible Pizza Company when they had a 72-inch diameter pizza, that's a lot of pizza. All right, we're going to deal with something called a sector of a circle, and I like to call this a pizza slice because that's what it looks like. A sector is a region bounded by an arc of the circle and two radii to the arc's endpoints. So if we draw a circle and we draw this, it's bounded by an arc and two radii. This is a sector of a circle. Looks like a slice of pizza, doesn't it? Alright, it's named using one endpoint of the arc, the center of the circle, and the other endpoint of the arc. So if these had letters to them, then that would be sector AOB. And the area of the sector is a fractional part of the circle. We have a formula for this. Okay, so for the area of a sector of a circle, for the area of this slice of pizza, you take the measure of the arc, just like before, over 360. So this would be the fraction of the circle, fraction of the circle, times the area of the circle, because you're taking some fraction of the entire area of the circle. Okay, so use this formula just like you did for the arc length. Alright, so let's try it. We're going to find the area of the sector ZOM of this whole chunk right here. So we take the degrees over 360 times the area of the circle. Our radius is 20. So we do 20 squared, which is 400, times pi. Okay, and you can reduce these like you did before. So if we do 70 over 360 and reduce it, it goes down to 1/5. So this is 1/5. So then to do our math, we would do 1/5 of 400 pi, which is 80 pi. But it's area now, so the units are squared. Okay, and then you could put that in your calculator and get 251.3 as your decimal if you needed it. But they told us to leave it in terms of pi. Alright, here we go again. It has a diameter of 20 centimeters, and it wants the area of a sector bounded by a 208-degree major arc. So we do 208 over 360 times the area of the circle. So we do pi times r squared. If the diameter is 20, the radius is 10, so this would be 10 squared times pi. Alright, we're going to type this all in our calculator. So we do 208 over 360 times 100 pi. And it says answer to the nearest tenth, so this would be 181.5 centimeters squared. Alright, now we're going to add to this just a little bit. So before, we were just doing the area of the pizza slice over here. But how many of you have those friends who cut off the crust off their pizza? So now we're going to find the area of the crust that they cut off. Okay? So to do this, you take the area of the sector, so of the pizza slice, minus the area of the triangle. This would be where all the toppings are. Okay? So we're going to take sector minus triangle. That gives us this crust out here called a segment of a circle, because it's just a portion of it. Okay, so we're going to be finding the area of the pizza crust that they cut off and leave behind or feed to the dog. Alright, so here we go. They want the area of the shaded segment, so that's this guy out here. Okay, so we're going to start out, we're going to do area of the sector. Okay, so this is the one you do the fraction of the circle times the area and get the area of just the pizza slice. So we have 90 degrees, so we'll go 90 over 360 times the area of the circle. The radius is 10, so we do 10 squared and get 100, so this would be 100 pi. And we're going to leave everything in terms of pi until the very end and then get to the nearest tenth. It makes our answer better. So 90 over 360 reduces to 1/4, just like it did before. So 1/4 of 100 pi is 25 pi. That's the area of the pizza slice before we cut the crust off. Then we're going to do area of the triangle, and that's a formula you probably should put somewhere. Area of a triangle is 1/2 base times height. Okay, so 1/2 times the base. So the base of this triangle is 10 times the height. Well, then you say, what is the height? We know in a circle that all the radii are the same length, right? So from the center to the circle is 10 inches, regardless of where it is. So OA is a radius, so it has to be 10. So that's the height of the triangle. So we do 1/2 times 10, we get 5 times 10, we get 50. So then to get the area of the shaded segment of the pizza crust, we take the sector, what we found for the sector, minus the triangle. So we're going to type that in our calculator. We get 25 pi minus 50, and we get 28.5 inches squared. And that's the area of that pizza crust that they cut off and waste away. Okay, let's try one more just to make sure. So with this one, a circle has a radius of 12, so that's important. Radius of 12. We want the area of the smaller segment of the circle determined by a 60-degree arc. So if you picture your circle, and here's your segment out here. This is your crust. Okay? And this is a 60-degree arc, so that means that this angle in here is also 60 degrees. Okay? So that triangle looks like this. And you know that two of the sides of the triangle are radiuses, so two of them are the same. So if you use your good intuition that you all have, that tells you that this triangle has to be equilateral. And that's helpful. Okay, so hang on to that thought for a minute. Alright, the area of the sector, so of the pizza slice, we do degrees over 360 times the area of the circle. So we do pi times radius squared. We get 144 pi. Okay? 60 over 360 reduces to 1/6. So we do 1/6 of 144 pi. We get 24 pi. Okay? That's round one. Round two, we're doing area of the triangle. So it's 1/2 times the base times the height. Now, we already talked about how this triangle is an equilateral triangle. That means that all of the sides are 12 because two of the sides were already 12 because they're radii. So then all of them are 12. Okay? Now remember back when we used to split these in half right down the middle and create a right triangle out of it. That splits the bottom 12 into a 6 and a 6. So you have a 30, 60, 90 triangle over here. Okay, so if you do a little Pythagorean theorem, you do 6 squared plus h squared for our height, because we need this height right here, equals your hypotenuse squared. And you do some math, you're going to come up with the height to be 6 root 3. Okay, if you don't believe me, then go through and do the math yourself and you'll see it. Alright, so we go back to our formula. We do 1/2 times the base, so the base is 12. The height, we found 6 root 3. So we're going to do the math. We'll do 1/2 times 12 and get 6 times 6 root 3, we get 36 root 3. So now to put it all together, we do area of the segment is the sector, so the 24 pi, minus the area of the triangle, 36 root 3. It says round your answer to the nearest tenth, so we're going to carefully type this in our calculator. 24 pi minus 36 square root 3, and we get 13.0. And then we need units. It would be centimeters squared because we're talking about area. Okay? Little involved, but not completely undoable. Alright? Good luck!